Class, in this week's lab, we're going to be working with the mineral samples in the rock and mineral set that you purchased through the OSU bookstore. I've laid out a collection of minerals here that illustrate different physical properties. You're going to be doing many of the same things that I'm going to talk you through here in the lab when you work with your samples. And in the lab, we're going to be describing the physical properties of the minerals that we have. And then we're going to use those observations of these minerals' properties to identify, if we can, what mineral we're dealing with. Now, the most obvious physical property is the color of the mineral sample. Because there's a limited number of chemical elements that are common, there's a limited number of different colors that are common in minerals, because color is a reflection of the composition of the mineral, what chemical elements make up that mineral. Minerals that are dark in color, and by dark we're talking about minerals that are green or black or dark gray or brown. Here's another green one. These minerals that are green, black, gray, dark brown, these minerals are said to be mafic, meaning they are rich in elements like iron and magnesium and relatively poor in elements like silicon, sodium, and potassium. Reverse is true for light-colored minerals. Light-colored minerals, meaning minerals that are white, light tan or silver, or even pink. These minerals are said to be felsic, meaning they're rich in elements like sodium, potassium, and silicon, and comparatively poor in elements like iron and magnesium. So in observing the color of the mineral sample, you're gaining insight into what its composition is, what elements make up that mineral's chemical structure. When you work with igneous rocks in your set, that's also a great time to think back and think about how minerals are related to rocks. Of course, igneous rocks that are mafic, iron and magnesium rich, igneous rocks like basalt and gabbro have lots of dark-colored minerals, green, black minerals, minerals that are rich in iron and magnesium. Felsic igneous rocks, light-colored igneous rocks like granite or rhyolite, are rocks that are rich in minerals that are light in color, contain elements like sodium, potassium, and silicon. A property related to color in minerals is the mineral streak. Now, to test for streak, you're going to take the small ceramic tile that was included with your set, and you're going to take your mineral sample. Let's do this one. You're going to take your mineral sample, and you're going to apply strong downward pressure onto that tile and produce a powdered or pulverized sample of that mineral. In many cases, the streak will be the same as the mineral's color in the hand sample. But in other cases, like this one, the mineral streak is significantly different from its color. Notice in the sample, the mineral is a purple color, but it streaks white. And so the streak is providing us additional information beyond just color alone. Let's check the streak of this mineral. This mineral it's grayish to brown. Let's see what color it streaks. Again, you don't rub the mineral on the tile. You apply strong downward pressure to the streak plate and grind your mineral sample against that ceramic tile. Then observe the color of the powder that you produce. This mineral is gray to brown in color, but it streaks a distinctive reddish-brown color. So again, streak is giving us more information than color of the sample is alone. Another property that's relatively easy to observe, but is somewhat qualitative or subjective, is the mineral's luster. How does that mineral reflect light? I would begin by deciding which of your samples show a metallic luster and which show a non-metallic luster. Well, a metallic luster, you all have in your mind what metal looks like. A nice, bright, shiny, metallic looking, for lack of a better word, luster. This mineral nicely shows a metallic luster. We have some other samples here that also show metallic luster. This guy does as well. It's not as bright as the metallic luster of this sample, but it still has the look that we associate with metal. So these two samples have metallic lusters. Our remaining samples here show non-metallic luster. Now there's a wide range of non-metallic lusters. Again, start by deciding, is the sample metallic or non-metallic in luster? If it's non-metallic, see if you can be more specific about the type of luster it has. Common non-metallic lusters include vitreous, which is the look of glass. The sample also vitreous. Vitreous is a pretty common non-metallic luster. All these guys show pretty good examples of vitreous luster. Even this one is still vitreous or glass-like. The luster of this sample is somewhat different. It's still non-metallic, but it's not quite the same as this one that we identified as an example of vitreous luster. It has more of the look of a resin or wax or almost like a candle. We would describe that type of luster as waxy. It's another non-metallic luster, but somewhat different from vitreous luster. Likewise, this sample, non-metallic, but not quite vitreous, somewhat waxy, maybe even silky or pearly. So you can see how describing luster is a somewhat subjective, qualitative exercise. It's an easy observation to make, but harder to articulate in a consistent, quantitative language. This sample, still non-metallic, but very different from the other lusters that we've talked about so far. It's much duller, more earthy in appearance, and the word we would use to describe that type of luster is earthy. In the next clip, we're going to talk about hardness, and then we'll go on to talk about cleavage and crystal habit.